Okay, I think we've got a good group of people, so we might as well get started. Just a couple ground rules and agenda items. We have until the top of the hour. So Trey and I are going to be presenting today, and we're going to try and keep this to hopefully about 45 minutes tops and allow that extra time for questions if you have any, or we can drop out a little bit early. The recording and the webinar itself will end up getting posted online. So I can talk to Kevin and just make sure that everyone who registered actually gets a link to that. If you have questions, feel free to ask them anytime in the Q&A. What we'll try and do is I'll go through an initial presentation, and then Trey will be doing the demo. And while he's doing the demo, I'll try and answer some questions, either directly online or we'll take them live after the demo is concluded. And just a reminder, as we talk here about time and how Fluree thinks about time, we did just do a webinar a couple months ago about scaling to the edge. And while the focus there was scaling, there was a lot of items related to time included in that, because we talked about how we can do time travel and treat time as events, but allow that to actually be a strength in how Fluree itself can scale dynamically. So for today, we have these 5 items to go through. We're just going to do a really quick intro to Fluree in case there's some new people here who haven't been introduced, at least to the very high level value points that Fluree brings. We're going to talk about time and immutability as it relates to a immutable ledger and how we're recording information in that ledger. We'll talk a little bit about how to access time, so that, you know, Fluree has notions of time built directly into it, but how do you actually query with time? And this gets into these concepts of bitemporal indexing. We'll talk a little bit about some ideas of different things that when you can wield time, what sort of benefits it offers you. And then we'll move in and show you a demo, actually showing some of the concepts and some of the time-related items directly in practice. Very simple demo that Trey put together, but he'll walk you through after that. So first, a little bit about Fluree. So Fluree is a data-centric platform. So it is designed to be able to hold strategic data assets such that multiple applications, multiple consumers can leverage those. And this contrasts from an application-centric approach, which is what I think we're mostly used to. But this is where the application is the center of the universe. And the only thing that accesses or talks to our data is the app itself. So getting into this sort of data-centric mindset, it enables a lot of very powerful concepts around data. A big one that we promote is being able to create data ecosystems, being able to enable more collaboration and more strategic value out of the data assets you have. But it also changes things because the architectures start to change a little bit when you think about this. I do want to point out as well, we have a lot of people that use Fluree just like a normal database as well. So there's some really neat things that Fluree does. We're talking about one of them today, including time, that traditional databases don't. So if you want to use Fluree in an application-centric environment, there's nothing stopping you from doing that. You can actually use it just like you'd spin up any other database and put an app in front of it. But it does give you this ability to extend well beyond that. So some of the differences and some of the things we need to address in this world, one is the interaction model. When we, let me just make sure I have my pointer, my mouse going here. Oops. One is the interaction model. So, you know, a typical database is designed to really just have one thing talking to it. It's a one-to-one model. There's only one thing producing data or telling it to update data, and there's only one thing reading data. There might be an exception if you put like a data lake or data warehouse, you're kind of ripping data out the back end of the application, but it's really designed for this one-to-one model. Whereas this data-centric paradigm is a many-to-many model. There's not only many potential apps or organizations or entities updating data, there's also many reading data. So in that model, things like security need to be addressed a little bit differently. Now, when the only thing talking to your data is the app, you can, of course, put the security for the data directly into the app. But when you have many apps, many things consuming data, and you don't want to get into the business of having to build and maintain thousands of APIs to get access to this data, you can actually embed security into the data itself. And we call this data defending itself in Fluree. We do this with smart functions. We're not going to talk about smart functions today, but that's an important concept in Fluree. Capacity, when you think about scaling this, when you have a lot of control over the data consumers, you have to worry a little less about scale because you have this single entry point that you have more control over. Whereas a data-centric world, you might have lots of people pulling data, lots of organizations. It's harder to control demand. So you need a much more sort of dynamic scaling capability in these data platforms, being able to scale linearly, instantly. And that, again, was a big topic of the last webinar that we did. And we actually did some demos in the AWS cloud that were dynamically scaling based on load. Things like data analytics. Here in the traditional world, you're looking at ETLs, processes, and in a data-centric world, you're looking at the ability to open up native rich querying interfaces that adhere to, it's not required, but potentially adhere to global schemas that can dynamically integrate systems together without having to build custom integration platforms. And in fact, I'll use an example from schema.org today in doing this. And then external consumption, if anything external needs to access that data, here you're in the business in the app-centric world of building custom APIs, maintaining custom APIs. Your customers or anyone consuming that data inevitably is also then in the business of building custom code to integrate with your custom APIs and then maintaining their custom code over time. Whereas in this data-centric world, because we're sitting on top of these layers of capability with data defending itself, et cetera, you can just query. You can just issue GraphQL queries, SQL queries. So you don't need, your consumers can start describing the data that they want, but they're only ever going to see the data they have permission to. If you look at a very high level overview of the architecture of Fluree, starting here on the right, Fluree has really two main components to it. One is the ledger backplane. It's actually probably most of the focus we have for today. These are just handling writes. They're just handling updates to the data. And the storage that this is using is very pluggable. We have object storage in the form of S3 right now. It can be in memory, it can be on disk. We have partners who are actually extending storage to be able to leverage other backend storage options. So this pluggable storage component enables that. The ledgers themselves communicate with a consensus protocol. This can be very fast. You can control all the ledgers. It gives you full redundancy across the ledger set. Optionally, it can even be decentralized. So you can actually run the ledgers or the backplane across even multiple organizations if you wanted to. The query side is just focused on data reads, and these are independent services that can scale up and down dynamically. They're stateless, meaning they don't actually need hard disk or anything. You can run them anywhere. You can throw them in Docker containers. You can throw them up in the cloud. They can go anywhere in the globe. They will dynamically get updates from the ledger backplane as writes are happening. And so you have this nice, very dynamically scaling capability for and horizontally scaling capability for your query servers. All interactions with Fluree go through a provenance layer that's able to track all the history. That's, again, going to be a big part of what we talk about today. Smart functions, we're not going to talk about today, but this enables you to create these very powerful rules around data, who can update data under what conditions, who can read data. And of course, the who becomes very important, and the identity layer here is able to answer that. So we know who is actually interacting with the system so that we can control all this security and permissioning. And ultimately, what you end up working with is a knowledge graph We allow this data to get represented several ways. You can, again, interact with it via SQL. You can treat it like it's a rectangular or sort of a table type of view. You can interact with it with Sparkle, which is the W3C standard for graph query. And this is naturally a graph database, or you could use GraphQL, which is kind of interacting with the data like a document database. So there's many different ways that machines can interact with it. Fluree also exposes an admin UI, a web admin UI, allows you to see what's going on with the ledgers and the network. Fluree has this really neat capability where you can actually take one of the database servers and actually embed it inside of your application. So your application now has a database running inside of it. You can just tell it, give the database a gig of memory out of my app server, whatever the case may be, and Fluree will manage that memory. But you really have an in-memory data structures now that you can query and get instantaneous response from. Today, we do this with Clojure. We do this with Node.js. We even have a version in JavaScript that you can embed inside of a web browser. It works as a web worker. And then the last way to interact with this data, and you'll see a little bit of this today, is through events. So as we're traveling through time, we're really just sending out deltas to the database over time. So it's really easy to set up listeners that are looking for specific types of data changes or anything like that that can trigger different data events. So at a high level, this is kind of what Fluree looks like. All right, so now to the main topic, time. So when we talk about an immutable ledger, we're going to represent the ledger over time here on the left. On the right over here, we're going to represent that if we looked at this data, not as a graph, but just in a simple spreadsheet format, what our spreadsheet would look like. And we're going to use this to kind of illustrate how Fluree goes through time and writes data. So Fluree stores its underlying data in the ledger in an extension of the RDF format, which people typically call triple stores. Triple because there's three main elements to it. As you can see here, there's a subject and the property or predicate, and then there's the value or the object that is being referenced. And RDF is just a really simple way of expressing any form of data. And a way to think of the subject is, if you're going to look at this in like a spreadsheet form, is the subject is the row, so the row number, the property is the column number, and then the value is the data inside the cell. So that's exactly what we're looking at here. So all of these things are row 123. And then we have A, which is the way to define basically a class in something. We have the schema name and the schema email. So we're using schema colon here to reference schema.org, which is one of these global vocabularies. So Fluree can leverage different global vocabularies, which allows you to start integrating data, making data containerized and portable, where people getting that data automatically know what that data means. Because instead of having some sort of cryptic or developer or application specific column names, for example, in a traditional relational database, we're starting to use sort of these globally referenceable schemas. You don't have to, you can create your own schema, but in this case, we're using schema.org. And all we're saying here is that we have this person, and we know it's a schema person, meaning it's a schema.org/person. So if you went to the website schema.org/person, you'd actually see a definition for a person and the different attributes a person can have. So row 123 is a person. It has a name, John, and John has an email, which is johnny@fluree.ee. So we see this in our spreadsheet format. Now, I said Fluree extends the triples a little bit in the ledger, and when we have to take into account time, we need to add some components to it. So one of the first things we do is we add this extra column here that determines whether or not this data is new data or it's data that's being deleted. And there isn't really a true notion of deletion. There's, we typically refer to these as being retractions, because data that used to be true can become false. And then what we also do is we have a reference to time. And there's a few different ways of referencing time. Just for simplicity, in this case, we're just going to use block, which is one of the ways Fluree references time. So these pieces of information were all added, and they were all added within the same block at the same moment in time, which is 21, block 21. So if we move forward a little bit here, And block 21, for example, has, this wall clock time associated with it. Can also have other notions of time associated with it. So now we're going to create another block, another moment in time, and we're at block 22. And you see here, we're adding, similar type of data. We're adding a new row, right? Row 124. It's going to be another person, and this time it's Jane, and Jane has an email here. Again, all true. So in our spreadsheet view over here, we just added another row, and there's the columns. Now, if we move forward again, we're going to do a couple different things here. We're now at yet another new moment in time, a new block. Some data was mutated. The identity of the person who tried to change this was proven. The smart functions were defined and allowed whoever made this change to make the data. And the change actually now happened within the ledger. So we're just appending the log here, but now with the new block. Now here we actually have incorporated a false. You see here that we're referencing row 123, which is what we created up here. And in this case, we're saying the email of johnny@fluree.ee is now false as of this moment in time, meaning we deleted it. It used to be true, but now it's false. And we're also right below it asserting a new email for John Doe. And we see over here in our spreadsheet that our piece of data got updated. It's now john@fluree.ee instead of Johnny. And at the same time, we also added a new row. We added a new person, Mary, and we didn't add an email address for Mary. But those are the pieces of information. And now we have this new version of our spreadsheet. Now, it's a very simplistic representation because what we're not really creating spreadsheets and versions of spreadsheets. We're actually creating entire knowledge graphs that can link to other data. They can, be represented in a rectangular form. So if you're very familiar with relational databases and SQL, you could still get to the data that way, but they're actually a more powerful connected graph that ends up being created. And in Fluree terminology, we didn't just create, this whole thing isn't just a database. What we say we do is that we're creating a new immutable database at every update. So we have a database that was created at block 21, a database that was created at block 22, and a database created at block 23. And all of those databases will forever be accessible, and you can query and access them anytime you want. And we do this very, very efficiently under the hood. So what we're really doing is we're just storing a series of deltas here. And we have very fast ways of being able to merge these deltas in and ultimately enabling time travel. So in this case, we created 3 databases. This isn't just one database. It's one append-only ledger, but we've created 3 different immutable databases out of it. So now that we have this notion of time, how do we access it? How do we start getting our hands on time when we need it? And I'll start out here with a simple query. Again, you can use SQL, you can use GraphQL. In this case, I'm going to use what we call FlureeQL, which is really a JSON version of the Sparkle graph querying language. One of the neat things about Sparkle, and in this case, FlureeQL, is that I'll focus really just on this where clause. The where clause becomes really easy to understand because when you understand what the data looks like, which we've shown here, the where clause is really just a filter on those same columns. So if we take this SA schema person, we can see all we're doing is really a matching on the columns. So everywhere there's an A will match, and everywhere A is equal to schema person, we match. And what we're gonna do, this question mark means this is a variable. We're just gonna bind the matching results to this variable. So in this case, S is going to contain 3 values, 123, 124, and 125, because it matched. In these statements, you can just build out, very detailed statements. You can put analytics in there, functions, aggregates. You can use optional and filtering clauses. There's lots of very powerful things you can do with these query languages. This is a simple example, but the roots of this are really nice because it's a very simple concept and aligns directly with how the data is stored. So let's focus on the select part. So now that we've bound the variable S to these 3 values, what does our select look like? What we're going to say is for all of those bound values, pull out the schema name and the schema email. So we want to pull out these properties. And ultimately, we're going to create this result set we see below. So We did not specify, this was just a plain vanilla query. We didn't specify a database to query. So Fluree just assumed for us, we probably wanted the most recent information. And again, a normal database is the only thing it can do. So we assume that's probably just what you meant. And our sort of world right here, the most recent piece of information we have is block 23. So that's what we're going to assume the user wanted when they issued this query. And here's our results. We pulled out the schema name and schema email as we defined in the select clause for each of those subjects. Recall Mary did not have an email, which is why we don't see an email coming up for Mary there. All right, so now let's layer in some time. So what if we wanted to issue the same query, but we wanted to specify a specific database that we want to query this for? We don't want to leave that out and have Fluree just use the latest version of the database. So here we're going to actually use the block number, and we're going to say we want to query the database that existed right here, not block 23. And the same query is going to produce a different result set because Mary didn't exist there. And actually, you'll see that the email address for John is now Johnny again because that was changed in block 23. Now, you don't just have to use block numbers. You can also use ISO 8601 time format. So in this case, we want to say we want to query as of June 15th at 12:15. And internally, Fluree will figure out what block or what moment in time that date is. You can also use a duration format. So this is the ISO 8601 duration format. P means we're doing a duration. Anything to the left of T is things like years, days, months. Anything to the right of T is minutes, seconds, hours. And what we're saying here is we want to query the database as of 15 minutes ago from now. And let's just assume that we were at block 22 15 minutes ago. So internally, Fluree is going to know that we're at block 22. And of course, if we want to then query as of block 21, we'll see our results change because that's all the data that was there at block 21. So it's a really easy way of accessing time within a query. We're just specifying the database version effectively that we're issuing the query against. There's a few different ways of leveraging time in queries. So I'm going to show you right here what we call a history query. So instead of issuing a standard query, what we're saying is I want to see the history of everything related to John Doe. And instead of querying a specific moment in time here, we're actually querying through time. So we want to see how all of the changes happen. And if we recall our data set at block 21 is the first time we added John Doe. And then block 23, we changed John Doe's email from Johnny to John. And we would see the results of this history query, every change that happened to this specific person through time. They can get more granular when you are doing history queries. I may only be interested in the changes to John Doe's email address, for example. So there's some different ways of doing this, but this is a good example of instead of querying a specific immutable database, now we're querying through time and actually looking at changes. Another thing you can do is actually query for the changes that happen in a moment in time. So if I want to see everything that happened in block 23, I can easily get that information out as well. And these were the set of changes that happened in block 23, if you recall. So now let's kind of build on top of that and look at querying across different moments in time simultaneously. So here again, just focusing in on our where clause. I lost my my cursor, so if you can still see it, I don't know where it's at this point. So ignore my cursor if you see it somewhere. In this where clause, what we're going to do is instead of having triples in each of these where statements, we're actually now going to have 4 elements in there. And the first element is actually the database to execute that portion of the query against. So you see in the first item in our where clause here, we're saying, take the current database, but we're using that duration format, query it as of 1 year ago. And bind anything with a product price to S. And then we're going to call the price that's actually stored in the database, we're just going to call it price old. And then the next line, we're saying just grab the current version of this database it's going to do an and condition on these S's. So it's only going to now have results where the subject or the row number existed in both versions of the data, and bind whatever its price is to just the value price, which is the current price. And then so we have some useful data. Instead of looking at row numbers, let's also grab out the product name. So again, we have the S listed one more time, and we're pulling out the product name and we're binding that to the variable name. And then you see in our select clause, what we're looking to do is just output the product name, the price, the current price, and the old price. And what you would see is results like this, like our widget used to be, or is $42, used to be $44 a year ago. The piping used to be, or is 14, used to be 10, and the price of the bracket here hasn't changed at all. So you can start to construct queries that are starting to go across time, because again, these queries actually allow you to join data across multiple databases. We have some examples in Fluree's documentation for even doing this with like Wikidata, which supports similar type of standards that we sit on top of. So Fluree gives us ability to query across databases. All the data doesn't have to exist in one database. And because every moment in time is itself just a different database, an immutable database that will never change, there's no reason you can't actually query across time and do joins across time. So that's a pretty neat concept as well. So just some examples. There's so many things you can start doing once you have a hold on time. We talked about these high-level value propositions and the environments Fluree's trying to enable, like collaboration around data. You can't really collaborate around something when it's constantly changing. So that's why time becomes very important in Fluree. We talk about provenance in Fluree, being able to see provable changes over time for data. But all these other kind of things just start pouring out of this capability. So one thing in our last company, we had a really big software as a service. This is actually a Netflix's microservices architecture you're seeing here. So in my last company, we had a big software as a service application platform. And we'd get these random errors from time to time that ultimately were race conditions for the data, because two different microservices felt like they had the same version of the data, but in between, as they're fulfilling a single request, the data changed, and they end up with inconsistencies, and it could break code further up. So a cool thing is that you can lock in the moment in time the initial request comes in, and every microservice can use that same moment in time for any data querying it needs. And they are guaranteed, even though they're completely distributed, they're guaranteed to always be looking at the same view of the world. You never have these concerns of race conditions. We've all had that situation where you've created a report. It's the report for the monthly results. You ran it on February 1st, and then somebody comes back and says, "Oh, could you add this column or this data to that?" And you can't, because the data's now changed. You can't reproduce the original report. Well, again, you can just modify the query in Fluree, specify that same, February 1st as of, 12 a.m. midnight, and you can reproduce the original data sets, extend it, and do whatever you like with it. UI pagination. I don't know if anyone's ever dealt with this issue where you have a lot of data that's changing frequently, but you're trying to paste results for users. Well, between when they're looking at the first page of results and the second page of results, the database is now changed, and they're seeing either a gap in data or extra data repeated. Here again, you can use that same moment in time you use for the original results, and you're guaranteed consistency across these requests. Troubleshooting and intermittent failure. I don't know if any of you have had this problem where, an integration process runs at midnight, you come in the morning and it failed, and you run it again and it succeeds, which is great, it succeeded, but you don't know why it failed. And you can't reproduce the state of the data easily for what happened, what caused the failure. So the only thing you know is that it's gonna fail again. Again, here, you can just grab the version of the data that can be locked in where that failure happened and actually evaluate the root cause and solve it. This is something that Trey's going to show a little bit of today. It becomes very easy to have user interfaces and capable of time travel. So you might be a customer support rep and you might be dealing with a situation where a customer called and said, hey, the price of this product was different yesterday. I swear it was, and now it's this. Well, typical database, it's like, I don't know what it was yesterday. Here you can easily go through time and see exactly what the data was, and it's all provable. If anyone's used Git in source control, Git blame for data, the ability to see how and when data got changed to understand the root cause. If you've ever had the situation where data has gotten committed and you didn't want it to get committed, but you've detected it a day or a week later, and then other data has sat on top of that new data, and you have this ability to, or this need to untangle all the data and get it back to a good state. Well, again, with Fluree, you could basically go back to the moment in time right before that bad data happened, effectively do a fork or a branch of the database, and then apply whatever you want to have on top of that. So having this history and just it's a great comfort knowing that you can understand exactly how your data got into the current state. And this is a really cool thing that we've shown and had a couple customers leverage is if you've ever built an app and you had the need, for example, to send an email to users at midnight of what's happened over the last day. Here's comments to your posts, or here's things that have changed that are what you're interested in. This capability gives you this very easy way of doing things like that, because what you can do is you can issue the query as of midnight today, and issue the same query as of midnight a day ago, and easily do a comparison to know exactly what has been changed in your data, and then perhaps use those deltas to craft like an email where you notify a user, here's what's happened in the last day, without having to trigger emails all the time. We've even put this together in a very sort of sophisticated and flexible system where you can store a query. You can store basically a cron schedule. So you can say, I want this query, the deltas checked every second, every minute, once a day, the first day of the month. You specify a webhook, so what service you want to call. So it might be like an AWS Lambda function that, again, is going to get like the data that's changed and maybe trigger an email. And then you specify the identity of the user, because again, data can defend itself, meaning each user might have different data that they can view. So data might be updated in the query results for a root user, but for that user, they might actually see no changes in the data. And just by storing those four things, you can set up a system that can automatically trigger external services at any schedule as any user identity. And whether that's posting messages to Slack or sending emails or triggering an analytics processing engine that's running an AI algorithm or doing something else, whatever you want to use that system for becomes trivial to do. And if you've ever had to build one of these without this kind of capability, you know how hard this is to build and maintain. All of a sudden it becomes easy and out of the box. So those are some things, just some ideas of things you can do with time. And I am here going to turn it over to Trey to walk you through an example. Oops.
Okay, thanks, Brian. Can you share my screen? My demo just disappeared. 1 second. Okay, there we go. Okay, so Brian touched on quite a few things that I'll be going over today. One of the things that I think about whenever I think about doing this time traveling is essentially Fluree has two different API endpoints that you can use to do these time travels. So there's querying across blocks, which I'll showcase first. And then there's also querying across using the history endpoint, which is the second thing that I'll showcase, which Brian showed for a second. But I'll go into a little bit more detail as well. So just to give a little context about the demo to start with, I'll just kind of go give a little brief overview of the data set that I put together to make this demo, to give you a little context about what's happening. So one of the things that I use fairly regularly, especially now that, travel's opening back up, is Google Flights. So to me, that's a really good way to illustrate the functionality that I'm going to be talking about. So Google Flights is a service where you can put in a departure airport and then an arrival airport, and then see all of the various options that you have for the airports that you have on different days, different airlines, the whole 9 yards, and select the ones that you want. So essentially what I did with my data was I made a data set for 5 days of next week. So this is going to kind of emulate if you were looking for a flight from one of 3 different airports to one of the other 2 of those same 3 airports between Monday and Friday of next week. And then I have flights for 8 a.m. and 3 p.m. for each of those flights. So what we'll look at is what happens when you query these flights and see what the various options are. When I was building the data set out, what I did was I went in and I created it as if each of the flights are being updated per day. So you can think of it like there were 5 different days with 2 flights each. And these would be updated kind of in batches. So you could say like the initial data set was transacted on Monday, and then all of the flights got updated on Tuesday, Wednesday, Thursday. And all of those prices that were changing and statuses that were changing were correlating to all of the flights that are happening next week. So that'll probably make a little bit more sense once I start getting into the demo itself. So what I did here was I'm actually using the React wrapper, which Brian made a reference to in his talk a little bit as well. This UI is actually running the Fluree query peer in a web worker on a thread next to the main application, which the UI is being run on right now. So I'm actually subscribing through the queries that I have transacted via my UI, subscribing to that data that's running on Fluree, also in my machine right now, but that could be running anywhere, either AWS or on one of your servers, wherever you have Fluree deployed. But as the transactions are hitting the ledger, the data that's stored currently in the web worker in my browser would get updated accordingly. So I won't be doing it in this demo, but for example, the data set that I have right now has 11 blocks in it. If I were to transact a 12th, with a full new kind of upload of all of the prices for all of the flights that we'll be looking at, this block would update, and all of the UI elements that would correlate to that would also be updated as well, because this is using React hooks, which is a kind of a real-time way to monitor the state of the application and then make the updates to the UI accordingly. So for the first couple of blocks, this was me just transacting in the schema. And then block 5 is where my first actual load of data got hit the ledger. So the 3 airports that I have are LAX, Atlanta, and then DFW's down in here as well. This is the status for that flight, the date time for that element, and then the price for that flight as well. So if I scroll down, essentially what we're looking at right now is the first data load. So say this had been uploaded or transacted to Fluree last Monday. At last Monday, this was the price for this particular flight at 3 p.m. from LAX to Atlanta. And it was, at that point in time, it was on time. So if I slide up to block 6, you'll see that it updates. And I believe one of these was delayed. Some of the statuses were modified as well, but all the prices should be getting updated also. I think if I click down here, yeah, so this one actually got canceled. And this is a relatively simple query, just like Brian was showing. All I'm doing is a select star from flights at whichever block I click at in the slider here. And I'm getting all of the data with all of the context that comes along with it. So if I wanted to have a weather reference in each one of these flights so that I could query an external database, like what Brian was talking about with Wikidata, where we were using the references in each of the subjects to query external to Fluree and pull in additional data, I could also be pulling in weather data. So you could think about running analytics on this to where you could correlate prices with weather data or something along those lines. I should probably also mention this demo is just a way to illustrate this functionality. This can be applied to whatever data set you want. This is just core functionality that you get out of the box with Fluree. And that kind of leads me into one of the other points that I wanted to talk about before I got to the history. If you imagine trying to build one of these with an SQL, like a relational database or a document database, you can see how quickly the complexity scales for something like this. At my last job, I was working on building out an API for the audit team, basically, and they wanted a way to track all of the applications at the place where I worked, and all of the deliverables is what they called them. But basically, they wanted to be able to track. They wanted to batch upload these things and then be able to track the history of those uploads and each of the deliverables over time. So the easy part was transacting that data into the database that we were using. We were using a relational database at that time. So we had the tables set up for each of the deliverables that we needed and all that kind of thing. But when you start considering how to build out the historical table, that's when things start getting complicated. You have to manage another API at a minimum. There's a whole other set of database tables that you have to manage the backups. You have to have basically a secondary team just to work on and build out the historical aspect of this data set. Not to mention that if you are doing joins or something like that, where you wanted to join from your historical table to either another historical table or to the, or to the current state of the data, it gets significantly more complicated, because if you wanted to see a relationship between something that happened in your historical table at the same time that was written in your historical table, managing that in another historical table and trying to build out an API that can easily query that is just a monumental ask. And I don't know that it's just very difficult. Whereas with Fluree, you literally just have to transact the data to the database. All of the indexing and time travel is essentially just surfaced to you through these two API endpoints. So as I said, when I query each one of these blocks, I'm essentially pulling in all of the context that happens at that point in time, along with the specific data elements that I'm wanting to look at. So all of the relationships and all the other pieces of data that were true or had been falsified at that particular point in time. So that's kind of, if you picture it as like a broad overview of the data at whatever point in time you're looking at. Brian mentioned using the ISO 8601 durations or date timestamps, or using specific block queries. You can even query, like if I just wanted to see block 4 through block 7, I could do that as well and just kind of take a slice out of the data set. That's possible as well, but that's kind of looking at a broad overview of the current state of the data at that point in time. So the history query, I think, is really interesting, because this enables something where, as opposed to looking at it broadly, you're looking at the evolution of a single subject as it's been modified over time. So say for example, what we're going to look at now, if I go to one of these later blocks where I'll have a little bit more history to look at. So we'll look at this LAX to Atlanta at 3 p.m. that had been canceled at this point in time. But if I look at the history, essentially what I can see here is at block 6, this was $680 and it was on time. At block 7, something happened, the price dropped, and it was also delayed. And you can just scroll through and see all of the updates that happened to this specific subject over time throughout the entire history of it. And the same sort of thing applies where with the block queries, you could query, at a specific moment in time, or from block 3 until the current state of the data. You can kind of modify your history query as well. But this is a really fascinating piece of functionality that Fluree enables, where you can look kind of down the length of that piece of data as it's been changed, as people have been transacting to your ledger over time. And again, because it's immutable, each of these blocks, each of these pieces of data, they're not going to be changed. There's no way to get into the database and say, at block 9, please update the flight for the LAX to Atlanta at 3 p.m. to, it was actually going to be $425. That's just not something, because of the immutability guarantees that we have, that's not something that's allowed. So, which brings me to another point. Another thing you can do with a history query is you can add the authentication records. So I'm not doing this here because I didn't get into the authentication stuff with this, but what you can do is you can say, show the authentication of each of the transactions that happened, and what would be coming back with each of these block queries or through the history query at each of these blocks is the authentication ID of the user who transacted that data into the database. What that means is you have an audit trail out of the box. All you have to do is pass an additional parameter with your query to Fluree to see whichever piece of data you want to look at. I want to see all of the updates that were made to it and who made all of those updates, and correlate those to whether those people had access or not, or verify that kind of the get blame that Brian was talking about, where you can go in and see, okay, who actually made this drop by $200 and why did that happen and who did that. So I think that's pretty significant functionality. And I believe that's all I had to demo. So I'll pass it back over to Brian and we can get on to the Q&A section.
Great, thanks, Trey. So we've got just a couple questions right now. If anyone else had any additional questions, please feel free to type them in as we answer this. But the first question here is from Rob. And I'm going to paraphrase the question, and hopefully I understood it correctly, except the question is getting into smart functions, and which smart functions, which we didn't really talk about a lot here today, but allow you to enable both what we call data to defend itself, but also allows you to create sophisticated rules around just data shapes and data constraints. So you can do things like say, a customer can only have an account, or someone can only be a customer if they actually have a valid open account and the account has a balance of at least $10. Like that could actually be expressed as a smart function. That has nothing to do with permissions, but that's just really constraining what the data has to look like. That same kind of capability can be used to say, the only person who can update flights, and Trey's example is a flight administrator, and they have to be on active duty, and they have to, work for the airline where the flight is originating from, or whose flight that is. So that would be another example of a smart function. So what starts to become interesting then is, how can you use time within smart functions? So there are a couple smart functions that allow you to just do raw queries. And with those queries, you can specify things like blocks. By default, when Fluree is applying permissions, it uses its own internal capability of very easily creating moments in time. And what it does when it starts a transaction is it takes the current state of the database and it calls this the original database. And then it actually applies all of the transactional changes to the database, and it has a new database created. Now it doesn't officially commit that database because we don't know yet whether or not that database is valid, whether it's going to pass all the rules. So out of the box, smart functions will, for any delete, so there's a number of smart functions that automatically kind of execute queries or check data behind the scenes. For any deletes, it always uses the old version of the database. And that kind of makes sense because you might have modified the data such that a rule might not even be checked or triggered in the new data. For example, if data is deleted, then there's no data there to actually validate a rule against. So any deletes, it's always using the old version of the database. And any adds, it's always using the new proposed version of the database before it's committed. So there is a little bit of magic that goes on behind the scenes there. One of the things that we're looking to add in the smart functions that are dealing with queries is allowing you to be more explicit about the version, the database version you really want to use within that query. So ultimately you will have more flexibility to do that. I think it's also worth just pointing out while I'm on that topic that Fluree also exposes this API we call with. So a database with other data. And just like that transaction example where it creates a proposed version of a database that doesn't actually get committed until it gets confirmed, you can actually do this, meaning that you can actually create proposed versions of the database, and you can create multiple of them. And it's basically, sometimes we call this forward time traveling, because you might take the current version of the database and then simulate data on top of that that hasn't really been transacted. But you can actually use that new version of the database just like it's any database. So you might run simulations. You might say, you know, assume this happens in our company over the next 3 months. I'm going to transact a bunch of fake data over 3 months. And I'm going to run this other simulation. And I can actually just put a front end UI on top of it, because your UI, as far as it knows, it's just querying a database. It doesn't know that these are, you know, fake databases or forward time travel. So that's something we didn't really get into today, but that's a pretty neat capability. The next question here is from George.
I can get this one, Brian.
Okay.
So there's no blocks because I transacted changes to that particular flight for each of the transactions. So had I skipped a block and not modified the price on that flight for whichever set of transactions I was pushing for that block, it would have skipped the numbers. That's purely a result of the way that I transacted the data to the database.
Okay, great. Thanks, Trey. So Robert asks a question here about representing a correction rather than a change. And I'm not sure I 100% understand the question, Robert, but I'll at least make a couple points about this. So something in the question is dealing with, you know, the true and false, asserting or retracting information. So there will never ever be a false within Fluree if that data didn't already exist somewhere. So basically, if you tried to delete a piece of information that never existed or doesn't exist, you would get an error with your transaction, which is what you want to have happen. You do have the ability to, so therefore anything that's falsified is something that had to have been true. There are some, so we talked about smart functions and applying permissions, and smart functions maybe constraining some data restrictions. You can actually use some of these functions directly within transactions. And one that comes to mind related to this question is compare and set. So right within your transaction, you can actually say you queried the database and you got out a value for something, say it was a counter, and the counter is currently 10. And now I want to update that counter to 15. You can actually submit the transaction, but instead of explicitly saying, just make this 15, you can do a couple things. One is that you can say add 5 to the counter, whatever the current value. So if Trey happened to update the counter already to 12 in between this query and this transaction, what it'll do is it'll just add 5 to 12 and the new value will become 17. Compare and set is another useful function to use in there. And what I could say is that only update this value to 15 if the transaction, or if the current value is 10. And the transaction will fail, and any other data in the transaction, the whole transaction will fail if that condition is not met. And then you can decide what to do from there. Maybe you want to issue a query again, get the current value and retry it, or, you know, whatever your application needs are, that can happen then. So there is a good amount of control. The other thing that is a little bit related to this question that I'll also just bring up is that we have in a beta format this capability. It's in our documentation. You might have to search for it a little bit on the website, called purging. And if a ledger is configured to be purgeable, it can actually allow you to physically delete, permanently delete data even from the history. So what Trey mentioned, you can never modify historical data, something that happened, but in this case, you can't actually purge it out. A couple things happen with the purge. One is that we actually record all the authentication identity information for the purge itself. So while it can permanently delete historical data and it no longer exists, there's actually a record of who deleted it and when it was deleted, along with hopefully some additional metadata, or at least a comment as to why you purged it. Maybe there was a legal reason, maybe it's a GDPR related thing. You know, maybe you have a policy that data older than 7 years can't exist. So there could be some reasons where legitimate purges are desired. And we do now have this in an early stage, we have this capability in Fluree to permanently purge data. Okay, next question. So Matthew asked, configure it such that Fluree can modify a piece of data when an event comes in. And can it support integrations from other systems by pulling of third-party information? So you can always use an external service that's maybe monitoring an external data source and then pushing data into Fluree. Transactions in Fluree are really just JSON, or in the newest version coming up here, JSON LD technically, but they're just JSON data. So you can construct based on, a CSV file or, some relational database, et cetera, and just transact JSON into Fluree. You can transact as much as you want into Fluree, and if the data already exists, it actually gets dropped out of the transaction. So it actually will automatically do deduping. I wouldn't recommend you intentionally sort of give it a bunch of data hasn't changed at all, because Fluree needs to do the work to see if that data still exists, and it's always using the current version of the database. So you're making Fluree do some work there. If you already know the data hasn't changed, then just don't send it. But you can actually just send an entire data set to Fluree, and it'll automatically dedupe the data. And you'll see in the transaction results, the modifications will only be the data that actually changed. Ruben asked a question about GDPR and immutability, and I think I actually just helped answer that question when I talked about the purge capability that I had mentioned. Yeah, so Juan asked about prefixes for namespaces. So Juan, this is, I'm gonna answer this, but I'm gonna answer this in the context of a branch of Fluree that is not part of the core sort of main Fluree release. So if you downloaded Fluree right now, at least our latest version, you wouldn't see this capability. But we actually have a prefixes table and a context table that allow you to load prefixes that can be used automatically within Fluree, or entire context in the JSON LDs, which is kind of like you're sort of providing components of a schema directly with it. You can also specify on a per item basis, or even at a transactional level, an upper level context to use. So this allows you to use prefixes without using a context at all. And because you have some saved in Fluree just as defaults. So if you wanted to use schema.org a lot, you might just have schema automatically mapped to schema.org, and you don't even need to supply a context. Fluree is gonna just default to, when it sees schema, to assume that schema.org. You can of course override that with a context embedded directly within your JSON LD. And then we even have this capability where we have embedded certain ontologies and context directly into Fluree, like things like decentralized identifier context, schema.org, a modified context, if you will, that has the data in there, that allows you to actually just start transacting schema.org data. And Fluree will not only transact the data that you supply with it, but it'll actually transact the schema elements that you're using if they don't already exist. So the first time you use schema.org/person, for example, Fluree automatically has a mapping of schema.org already inside, and it'll create schema.org/person inside of your schema, inside of Fluree itself, the first time it's actually being used. So there's some really neat stuff we're doing there, and all of this is going to be part of the final version 1.0 release. Okay, so Benny points out that some ERP systems have the capability of data effective, corrective, and that's true, I think, to some degree, although at least a lot of the systems that I have used store key pieces of information in kind of a history table. And you actually don't have a completely recreatable version of the entire state of data, which includes relationships and et cetera. So if you're looking at an HRIS system, they might explicitly, for good reason, record an employee's salary history and maybe the employee's job title history. But if I wanted to take a look at the point the employee's salary was X, who was their manager, and what was the manager's salary, and what was the manager's email? being able to stitch those components together is not necessarily a native thing. Yeah, so I think recording, sort of journaling out data can be quite a bit of work, and it's software, so anything is possible. So Rob asked a question about provenance info from history being used in smart functions for access control. And yeah, you know, inherently smart functions are using, oh, you're saying the history data itself. Yeah, so there's a smart function called just query. And while I haven't looked at it recently, I believe you can issue either a block or a history query or other things directly within it. And then you could perform logic with the results. So I believe, Rob, the answer is yes, although I have never personally done it. So I would have to verify that that works as you describe it. So Lisa asks if you can mask data when querying it based on access to the individual. Absolutely. I mean, this is part of the power of Fluree. So you'd have a smart function that says, for example, you can only see social security number if it's you, or maybe if it's the HR person assigned to you. So only 2 people can see SSN. Well, anyone, any app, anything, any partner, any whatever can issue any query, but when they issue it, that query is tied to an identity. That identity would then filter out all the data that that user can't see. So if the user said, you know, select star from employees, they might see every employee's first name if you allowed them to, but social security number would only show up for themselves. Or if you were the HR person, the social security number would only show up for the people that you're associated to as the HR person. So absolutely, that's one of the really cool things that smart functions can do. And then last question here, when are we going to officially release 1.0? And the answer is sometime in Q3. So anywhere really probably from a month to 2 months from now. So we very much want to make sure that 1.0 is a product that never has any fundamental breaking changes to it, breaking API, changes that might need to be made. So we're actually really going through kind of the, I'd say 2+ years of experience with Fluree out in the field to make sure we have all the underpinnings exactly how we think they need to be based on that actual usage, so that when we release officially version 1.0, we will never, ever have a breaking change to any future version. So that's one of the reasons we're just taking so much time and care on the 1.0 release. After 1.0, I think you'll see releases come out quite frequently, and it will be our goal to never, ever have a breaking change. And I think that's all the questions. Well, thanks everyone for sticking around. And like I said, we will end up putting out a recording of this webinar. If you have any questions, please reach out to us. If you haven't already joined the Slack channel, please join the Slack channel, the Fluree Slack channel. You can find that on our website. And go ahead and ask questions there as well. And we monitor that and try and get questions answered as quickly as we can. Appreciate it and have a great day.